Hello my dear student, welcome to Nagesh Karasge Orchid School channel. Myself Hina Patel going to teach you 7th grade mathematics. Already we had started with the symmetry chapter. We had seen in the previous session rotational symmetry, clockwise and anti-clockwise. Today we will have a different order of an symmetry. Today we will have some examples related the one order of a symmetry, two order of a symmetry. Already we had seen in the previous session of 4 order of symmetry. So, one by one we will have a rotational symmetry, we will have some examples and we will find the order of rotation. Here we are having some example. Stick a pin in the shape at a point O. One figure is given to you, just we have to just put a pin. Why we are putting the pin here? One is shaded figure and one is unshaded figure. So, you know the center, just we are putting a pin at the center of this figure. We have to find out clockwise and anti-clockwise directions. Yes, and we will find out where the point or axis vertex are coincide to each other. So, here stick a pin into a shape at a point O. This is a point O, just we have to put a pin. Now, turn the transparent shape in the clockwise direction. This is transparent shape, you have to turn into a clockwise direction. How many times do the shapes coincide in one full rotation? In one full rotation, how many shape coincides? What is the order of rotational symmetry? Here just have a one practical activity here you can do on a paper. So, you will understand the number of rotation as well as the order of rotation. Here another example, the point where we have a pin is the center of rotation. Yes, everyone knows where we put the pin, that already we had seen spinning wheel. Center of rotation, it is the intersecting point of and diagonals in this case. This center of rotation is nothing but here we are having some diagonal, that is nothing but intersecting point of an diagonal. Every object has a rotational symmetry of order 1. Each and every object has an order of symmetry as a rotational symmetry as 1, as it occupies the same position. It occupies the same position after a rotation of 360 degree also, means it comes its original position. After rotation they comes its into the original positions, means there is a one rotation which is a complete rotation, that is 360 degree. So, each and every object have a one order of rotation, that is one complete revolution. Such case have no interest for us, no intersect for us. So, you have around you many shapes which possess a rotational symmetry. This is, you can find out this have a rotational symmetry. This is a lemon, that is if you go for the orange, if you find in the sweet lime this type of a rotational symmetry, you can find the number of rotation here, and this is a road sign which you find on the road or signboards, and wheel of a bicycle or wheel of a car, you can find this, or if you are having a toy car or toy vehicles, you can find the rotational symmetry in this. So, in this we can find a symmetry, how many orders also we can find out. For example, when you slice a certain fruits, the cross section are the shapes with an rotational symmetry. This might surprise you when you notice them. If you every time we eat the fruit, sweet lime or orange, but we have never noticed this. If you now notice, you will find surprise because you will relate it with your studies now. So, then there are many road signs that exist a rotational symmetry. Next time when you walk along a busy road, try to identify such road signs and find about the order of rotational symmetry. Order of rotational symmetry. How many orders of rotational symmetry? Think of some more examples for the rotational symmetry. Discuss here we are having the center of a rotation, an angle of a rotation. This you have to find out when you pass through a busy road, or you can find out in the when you have a cross section of a fruit, that is lemon, orange, even the wheel of your bicycle, car or toy car, and the directions in which the rotation is affected and the order of rotational symmetry. How many order of a rotational symmetry we can find out. So, we will see some example sums with our exercise, so it will be more easy to understand. Here the same we have to find out, that is a rotational symmetry of order more than 1. So, we can find out the rotational symmetry order here. Shapes are given, that is circle, we have a triangle, some different shapes we are having, we have to find out its rotation. Here we will go one by one. The given figure, first we will consider a figure which was in a circle. You can see here we will have how many rotation and the order. The given figure has its rotational symmetry as 4. This is the example in the previous class I had explained you. Here one rotation, that is 90 degree, another rotation, yes, 1 to 90 and 90 is 180, then third rotation, that is 270, and again the third rotation, and again we will get into original position, that is fourth rotation is total completion of a one rotation, that is nothing but 360 degree. So, 1, 2, 3 and 4 rotation. This 1/4 we are taking at 90 one time, this is another one time 90, again third time 90, and this is fourth time 90. Then after this completion, again we will have this original position. So, there are 4 rotational symmetry. This was a circle, very easy. Now, the given figure is a triangle. The given figure has its rotational symmetry as 3. You know the triangle, just to have a imaginary line, draw with a dotted line and find out the number of rotation. Now, you know this triangle is divided into 3 equal parts, yes. So, we will have a 1 rotation here, then second rotation, and this will be the third rotation. So, we have a 3 rotational symmetry in equilateral triangle. The given figure has no rotational symmetry. See, this is a figure we are unable to rotate. So, no equal symmetry, we can't draw a symmetry here exactly and we can't rotate it. So, there is no rotational symmetry in that. Now, we will see with another example, the given figure which is in the shape of a H, we will have a 2 rotational symmetry, that is which will look like a same to its original position. Again a H, this is one rotational, that is 180 degree, and this will be the another 180 degree. So, it is doing a rotation of 360 and we will have a 2 rotational symmetry, that is 1 and this is 2 rotation. So, in this way we can find out the two rotational symmetry in the given figure. Here we are having a square, circle. In this circle already it is given to us with a circle is divided into 3 equal parts. So, no need to go for any lines of a symmetry, just we have to find out a rotation, one rotation symmetry, second rotational symmetry and 3 rotational symmetry. So, circle, the given figure, I can't say circle, the given figure have a 3 rotational symmetry. Here the same is nothing but a spinning wheel. The given figure has its rotational symmetry as a 4, we had seen the order as 4. So, this 1, this will be the second, this will be the third and this will be the fourth. So, it has a 4 rotational symmetry, just you have to draw this figure and you have to show the rotation, this is one rotation, second rotation, third rotation and fourth rotation. So, it have a 4 rotational symmetry. Now, we are having some order of rotation symmetry of each figure. Now, they had given the order of rotation, here some we have to draw it by dotted line. Here the given figure has no line, has its rotational symmetry as 2. Why? Because it's rotate from the center of the given figure. You can find out small x over here. It will rotate again from the come to the original position after rotation, that is one will be this 180 and again another will be another 180 in this. You can, if you color here, you can find out a 2 rotation. If you color here, you can find out 2 rotation and we can say its rotational symmetry as 2. Now, we will see about this figure 180, this will be 180, degree, again it will rotate, with a dotted I had showed here. So, again it will rotate at 2 in this position as 180 degree to find out its. So, here we can say its given figure has only a 2 rotational symmetry, only 2 rotational symmetry. See this dot, if you rotate here again you will get the dot, that dotted part in this which is shown in the second figure. So, it is rotate at which degree? 180 degree, rotates at 180 degree. This also I told, just I had put the dot over here, again it will rotate at 180, the dot will be in this position. So, it rotates at 180 degree. Similarly, here it is one rotation, second rotation and third rotation. It is an equilateral triangle, just we had draw this, divide this triangle into 3 equal parts, where already it is given the center of this triangle is given by putting a small cross. By that we have find out the rotational symmetry as 3. Here the given figure has a 4 rotational symmetry, which is the example of an spinning wheel. So, the same when you prepare it, I told the activity, if you prepare you can find out a 4 rotational symmetry. In this given example, here just they had put a given figure, just I had put the dot over here. So, we can find out the number of rotational symmetry. So, if we rotate to the 90 degree, the dot will be here in this position. If we rotate again to 90 degree, the dot will be in this position. And if you rotate again to 90 degree, the dot will be in this position. Again if you rotate to 90 degree, it will be in the original position. So, 90, 90, 90, 90 is nothing but 360 degree, the one rotation is completed. But how many rotational symmetry it have? It has a 4 rotational symmetry. Here the given figure, if we rotate here, if you divide this figure into 5 equal parts, as an pentagon, it rotates at 72 degree. The one angle of this is 72 degree. So, when it rotates, just I am putting a dot here, that after rotation of 72 degree we will get the dot over here. After rotation of a 72 degree we will get the dot. In the similar way, we complete this rotation, we will have how many rotation to get it to its original position? We are having 5 lines of symmetry. So, in this way we are having some more example you can find out. This is again nothing but a example of a ceiling fan. You can find out this is the blade of an fan which rotates at 120 degree. So, it is total rotation will complete one rotation is 360. So, there are 3 rotational symmetry. So, in this way we had find out the number of rotational symmetry here. So, name any 2 figures that have both lines of a symmetry and rotational symmetry. Lines of a symmetry, equilateral triangles, you know, and a regular hexagon have both line of symmetry and a rotational symmetry. Lines of symmetry you can draw with a dotted line. Rotational symmetry, you have to find out the angle and you have to rotate the how many time it gets rotated to find its original position. So, now draw wherever possible a rough sketch of a triangle with both line and a rotational symmetry and order more than 1. A triangle with only line of a symmetry and no rotational symmetry of an order more than 1. These are the example given that we have to draw the rough sketch and we will find out the lines of a symmetry and the rotational of this. Equilateral triangle, you know, we have 3 lines of a symmetry, just we had drawn and we have to find out the order of a symmetry. So, we had drawn the equilateral triangle divided into 3 equal parts 120 degree, it has a 3 order of symmetry, more than 1 it is asked in a question. So, we can find out it has a 3 order of symmetry. Isosceles triangle, you know, isosceles triangle has only one line of a symmetry and no rotational symmetry, that it has only one. I told each and every object has only one line of a symmetry, each and every object have one. Now, we are having a parallelogram is an quadrilateral which has no lines of a symmetry, the example of a no lines of a symmetry, but a rotational symmetry and of order 2. We can see the order of rotation. If we are putting a dot here, it will rotate one on and it will get the dot here. By putting the pin in the center, I told example we can rotate here, it was a similar example. So, we have a 2 rotational symmetry, that it is rotate at 180 degree. These are the many example given related to the exercise, and we can find some more example by figure. 2 or more lines of a symmetry showed its rotational symmetry of order more than 1. Yes, if a figure has 2 or more lines of a symmetry, then it will definitely have its order or rotational symmetry of order more than 1. One rotational symmetry, you know, each and every figure have a rotational symmetry. Now, we will see here the tabular form which will give the all the ideas, what are the different shapes and what are the number of rotation and the number of axis of symmetry and what is the angle of rotation and the center of rotation. Now, shape is given to us the square, rectangle, rhombus, equilateral triangle, regular, hexagon, circle and semicircle. Center of a rotation and order of a rotation and angle of a rotation. Now, you know very well because we had seen some example. So, what will be the center of rotation? Yes, we will have a center of a rotation where the intersecting points of a diagonal square. Yes, we will draw a diagonal and we will have a center of rotation as a where the intersect, that both the diagonal intersect, and we can have a order of rotation as a 4 Now, just imagine in the previous class I had explained you the rotation or order of a square which we had find out with an examples. So, that is order of a rotation is 4 and angle of rotation is 90 degree, 90 degree, 90 degree, 90 degree and 90 degree. So, one rotation, to complete one rotation again to original position, that is complete 360 degree. Rectangle, again it has a center of rotation. Yes, how we will find the center of rotation? By drawing a diagonal, and that diagonal where they get intersect, that intersecting point of a diagonal is nothing but a center of rotation. Here it will rotate at 180 degrees. So, we will have only a 2 order of rotation, only 2 order of rotation. So, we can say rectangle which have a 2 order of rotation at which is at 180 degree. It is not a rectangle only, you can find out some rectangular shape, any a shape which is some object of a rectangular shape, you can have only a 2 order of rotation. And again you know the lines of symmetry also, we have a 2 lines of a symmetry. Rhombus, again we will find an center of rotation, that by drawing a diagonal, that is diagonals, and where these 2 diagonals intersect at the point, that is nothing but center of rotation. And order of rotation is 2, similar as a rectangle, you know the shape of a rhombus. So, we will have a order of rotation as a 2 and it is rotate at 180 degree. Now, equilateral triangle, what will be the equilateral triangle? Just imagine equilateral triangle in front of your eyes, and there we will find an intersecting point, where again we will draw a diagonal from the vertex of this triangle, where the point of intersection we will find, that will rotate a 3 order of rotation that we will have, and which is of 120 degree. Here 120 degree, just we can measure with our protractor when you have drawn an equilateral triangle, and 3 rotation means total when to complete one complete rotation is nothing but 360 degree, but it rotates rotational order of rotational is 3. So, we divide 360 by 3 is nothing but 120 degrees. So, each rotation of angle of rotation of an equilateral triangle will be 120 degree. So, 120 degree one time rotation, then 120 degree second rotation, again 120 degree third rotation, it completes 360, that is nothing but again that equilateral triangle will be in again original position. So, we can find the number of order of rotation as well as order of a symmetry, that at angle of rotation is what degree it is at 120 degree for equilateral triangle. Then what about the regular hexagon? The word is regular, so all the sides of an hexagon is equal. So, here we will have 6 vertex, just we have to draw and diagonals on this, just join all the vertex of an regular hexagon, we will find an point of intersection, that point of intersection is nothing but an center of a rotation. Just if you put a small pin over there and if you rotate this regular hexagon which you had drawn on the piece of a paper and cut it properly, then again it will rotate. Just I had told example, while preparing a spinning wheel, you can just color one of the blade of this and you can find the number of rotation as well as angle of rotation, finding the center of a circle, center of rotation, sorry. So, in this way in the regular hexagon we have a order of 6 rotation, 6 rotation. So, 160 divided by 6. So, to get it complete rotation is nothing but 360 degree. So, each rotation is of 60 degree, each rotation is 60 degree, and circle you know very well, circle has a infinite line of a symmetry, it has a circle center of a rotation. Yes, it has a center of rotation by drawing infinite lines of a symmetry. So, it has a center of rotation, and the line order of symmetry order of rotation is infinite, and the line of symmetry is also infinite, and angle of rotation, any angle, if you draw only 4 or 5 lines of lines of a symmetry in the circle, that will have a different angle. If you draw more lines of a symmetry, then it will rotate, the angle of rotation will be infinite, and but it will be rotate at different angles. Then what about the semicircle? Semicircle, the center of rotation, yes, we will have a center of rotation, and order of rotation is 1. I told each and every object has a 1 order of rotation. It will rotate one time to complete its to again come to this original position as 360 degree. So, 1 order of rotation, the angle of rotation is 360 degree. So, in this way we had find out the different figures, the center of rotation, order of rotations, and angle of rotation. Now, we will have some example of a quadrilaterals which have both lines and order of symmetry of a order more than 1. Square, rectangle, and the rhombus are the quadrilateral which have both lines and the rotational symmetry of a order more than 1, and the square has the 4 lines of a symmetry and rotational symmetry of order 4, as a rectangle has 2 lines of a symmetry and the rotational symmetry as order 2, which already we had seen, just we have to collect and we have to write the names of it. Now, after the rotating by a 60 degree about a center, a figure looks exactly the same as its original position. At what other angles this happens for the figure? Now, yes, if the figure looks symmetrical on a rotation by 60 degree, symmetrical means exactly the same after the rotation of a 60 degree, then it will also look symmetrical on the rotation by a 120 also, 180 also, and 240 also, and 300 and 360, that is further multiplications of 60 or multiple of 60. So, in this way we have find out if it rotates at 60 degree, yes, at the 60 degree that rotational symmetry will look like the figure will look similar. Can you have a rotational symmetry of order more than whose angle of a rotation is 45 degree and 17 degree, 45 and 17 degree. If the angle of rotation of a figure is a factor of 360 degree, I told that time we can divide, that we had seen the 6 rotations, so each angle was 60 degree. If we have a factor of a 360, then it will have a rotational symmetry of the order that 1. It can be checked by a 45 degree will have its order of symmetry of order more than the 1. However, the figure having its angle of rotation as 17 degree will not have its order of symmetry of more than 1, because you know we do not have a factor as of 360 as a 17. So, it is not possible to find out the order of a symmetry when we are having a angle of 17 degrees. So, there is only a 1 order of a rotational symmetry. So, in this way we had seen the rotational symmetry as well as a center of rotation and the angle of rotations of a different figure. Hope so, my dear student, you have understood this. Just to go through the lesson, just to find out the figure, you can create your own example. Thank you very much.